Let's take a look at example problem 6.2.2, a summing circuit. So in this problem here, we have a figure that shows a circuit for summing the voltages V1 and V2 to produce the voltage V3. They want us to derive the expression for V3 as a function of V1 and V2. For the case where our resistances R1 equals R2 is equal to 10 ohms and R3 is equal to 20 ohms. Down here is the circuit that they give us here. You can see our voltage here, V2, negative, positive, and we have our current I2 here, our resistor R2. Come along down here, we can see there's our ground there. Here's our voltage source V1. Coming up into our resistor R1 here. Here's our current I1 there. Here's our voltage V3 down through resistor R3 and our current I3 there. So now that we've read through the problem statement, taken a look at the given diagram, and seen what they're asking us to solve for, our next step is to create our setup page. That's what we do here. I have my title, ME111, example 6.2.2, title the summing circuit here. My given values here, I have my R1, which is equal to my R2, which is equal to 10 ohms. I have my R3 is equal to 20 ohms there. And I have a redrawn circuit right there. And down here is my find section. They're asking me to look for. They want me to derive the expression for V3 as a function of V1 and V2. For the case down here, again, where my R1 and my R2 are equal to each other, is equal to 10 ohms. And my R3 is equal to 20 ohms. So as we begin our solution here, I redraw out my diagram just so I have it right on the same page. What I want to do now is take a look at, let's do one resistor at a time. So we're going to focus first on our resistor R3. So we pull that from our diagram up here, and we can see, okay, for resistor R3, I have my voltage V3 here. Here's my resistor R3, and here's my current I3 here. Recall Ohm's law here, Kirchhoff's law. We have V is equal to IR. We can plug in for our specific problem here, where V becomes our V3. My I is my I3, and my R is my R3 here. Rearrange it, solving for my I3. What I have here is that my I3 is equal to my V3 over R3. So that was relatively straightforward for that one there. Let's continue on, do the same thing for R1 and R2. So we'll go to R2 here. So for this part of the circuit, our R2, we redraw just that out there. Okay, here's the voltage source on one side, my V2. Here's the voltage source V3 on the other side, that there. Here's my I2 current and my resistor R2 there. Start off again with V is equal to IR, my general equation there. So the voltages I have here, I have my V2 positive from over here, and I have my negative V3 from over on this side of it here. So that is equal to my IR side. My I is my I2 here, and my R is my R2 right here. So I can plug that in. V2 minus V3 is equal to I2 R2. Solve this for my I2. What I end up with, the I2 is equal to V2 minus V3 over my R2 right there. So I want to do the same exact thing now for my resistor R1. Redraw that part of the circuit there. Just take a look at that part from your whole circuit. And again, I have now my voltage source V1 coming up here. Across my resistor here is my current I1 there, and the voltage V3. So my voltage from V equals IR, my voltage is my positive V1 and my negative V3 here, is equal to my I1 current right there and my R1 resistance right there. Plug that in, and now I can solve this for my I1. When I do that, I have that my I1 is equal to V1 minus V3 over my R1. So we can see from our circuit that there is no capacitance in the circuit, therefore no charge can be stored anywhere in the circuit. So if we know that there, we can then use our conservation of charge. And our conservation of charge gives us that I3 is equal to I1 plus I2. So we can substitute the expressions for the circuits into this equation above here. So if we plug it back into this equation here with our expressions for the circuits, we end up with is for I3, we have the relationship of I3 is equal to V3 over R3. For R1, we have I1 is equal to V1 minus V3. And for I2, we have the fact that I2 is equal to V2 minus V3 over R2 there. So from that there, we can put those back in, plug it in. We end up with V3 over R3 is equal to V1 minus V3 over R1 plus V2 minus V3 over our R2 right there. So from that equation, we carry that over right in the top of our next page for our solution here. And we know from our givens that R1 is equal to 10 ohms, R2 is equal to R1, so that's equal to 10 ohms, and our R3 is equal to 20 ohms. So we can plug that in for those equations there. So what we end up with when we have our equation from above there, we plug in for our R3, R1, and our R2. So we have V3 over 20 is equal to V1 minus V3 over 10 is equal to V2 minus V3 over 10. We can reduce and simplify. We'll combine the denominators on the right side over here to 10, and we'll have the numerators come across here. So we have V3 over 20 is equal to V1 minus V3 plus V2 minus V3. Combine those two V3s together, we end up with V3 over 20 is equal to V1 plus V2 minus 2 times V3 all over our 10 here. So then we can multiply both sides by our 20 right here to move that over. We end up with V3 is equal to 20 times V1 plus V2 plus 2V3 all over 10, so we can cancel that out. We're left with just a 2 there. So V3 is equal to 2V1 plus 2V2 minus 4V3. Well, let's add a 4V3 to this side, add a 4V3 to this side. So we end up with 5V3 is equal to 2V1 plus 2V2, or 5V3 is equal to 2 times, pull that 2 out front, V1 plus V2. So we can move things around, divide both sides by our 5 there. We end up with V3 is equal to 2/5 V1 plus V2, or V3 is equal to 0.4. We take 2 divided by 5 of V1 plus V3 for our final answer down in the bottom here. So therefore, V3 is proportional to the sum of V1 and V2.